Number 14, the function f is defined by f of x equals x minus 6 times x minus 2 times x plus 6. In the xy plane, the graph of y equals g of x is the result of translating the graph of y equals f of x up 4 units. What is the value of g of 0? The big thing here is translating the graph up 4 units. They like this type of problem of take a function and then translate it up, left, right, down, whatever. There are some basic rules for translating and how to change a function to translate it. Make this very, very simple, but you do need to know these rules ahead of time. So I'm going to go through all of them. The easiest way to do that is to show you in Desmos. And I'm going to start with a basic f of x equals x squared. That's just a standard run-of-the-mill little parabola. Now, these first 3 here are the ones that are most likely to show up on the SAT. I'm going to show you the others really quickly just so you have them under your belt. But here's the big ones. To move it up or down, the number has to go on sort of the outside of the main function. Whatever little function, whatever you've got going on, you got your x squared, x cubed, square root of x, whatever. This plus 2 here, this number on the outside, that's where it needs to be, outside. It's going to move it up or down, and it's going to do it directly. So if this is a plus 2, it's going to move it up 2 towards the positive 2, the positive y. If it was minus 2, it's going to move it down. Nothing else changes. I'll turn it on so you can see that. There you go. It just moved up. That's all it did. This is the same parabola. It just moved up. Now, if we want to move it left or right, that number has to go inside with the x, with the main x. And it's going to do it in the opposite way. So this plus 2 that's on the inside of this x squared with the x, it's going to move it towards the negative x, negative 2. If I wanted to move it to the right towards the positive, I would need to make this a minus 2. So this is plus 2, so it should do the opposite, go to the left 2, and there it goes. When I turn it on, you can see it. You absolutely can combine these. So here we have x plus 5 squared minus 3. That plus 5 should move it to the left towards the negative x, 5, negative 5. And the minus 3, it should move it down 3 on the y. So let's turn it on, see if that's right. Yep, there it goes. So it moved, and you can, all you have to do really on this one is kind of track that single point, and you can see that it moved to the left 5 towards negative 5, and it moved down negative 3. And you can do that with any point on here. If you were trying to do this by hand, you could just pick a point and then move that down 5 to the left 3. You'll have your new point. That is really what you need for the SAT. For your math class, you may also come across this one, negative x. The negative flips it upside down. If you put a number in front of it, if that number is greater than 1, it's going to squish it horizontally. It's going to make it narrower, so like that. And if the number is a fraction between 0 and 1, so it's not quite 1, but it's not negative, still positive, it's going to stretch it. It's going to make it wider horizontally. And there it goes. Just to show you how this works with other things, here's an example with square root of x. Same rules apply with functions. Here I have that minus 2. It's outside of that square root, so it should move it down 2 because it moves it on the y, and it moves it just like you see it. Sure enough, it moved down 2. This one, it's inside with the x. It's going to do the opposite. It's going to move it towards the right, towards the positive x, positive 2. There it goes. It moved to the right 2. And same thing to combine this, same one. That's moving it to the left 5 and down 3. And there it goes, left 5 and down 3. So those are the rules of translation. So here, for this one right here, to translate this thing that we were given, f of x equals x minus 6 times x minus 2 times x plus 6. To translate it up 4, all we have to do is add 4. And now it is no longer f of x. The problem tells us this is g of x. G of x is when we move it up 4. So there's our g of x. We don't have to multiply these together. We don't have to go, okay, what's FOIL? Let me do the FOIL method, and then we'll multiply that. No, that is unnecessary. Total waste of time. Don't do that. This is one of those problems that if you know how to translate things, you know the up, left, right, down, and where to put that, that number to make it happen, it's going to be very quick. If not, you're going to be probably struggling with the graphing calculator for a while trying to figure out what to do to move it. That's why this is a really good one to learn, because it makes these problems so quick and fast. You go, oh, move it up 4, add 4. Okay, now what do I do? Now we want to know, what is the value of g of 0? Evaluate this function when x is 0. All right, so g of 0 just means everywhere there's an x, we're going to replace it with a 0, and then we do the math. You also, at this point, could put your g of x into a graphing calculator and see what the y value is when x is 0. That's possible too. Both are valid. It's just whichever is faster and whichever one you're more confident in will give you the right answer. Those are the two factors I always tell everyone to take into account. All right, let's do this math. 0 minus 6 is negative 6. 0 minus 2 is negative 2. 0 plus 6 is 6. We need to multiply those together. Negative 6 times negative 2 is 12. 12 times 6 is 72. Now we can add our 4. 72 plus 4 is 76. And that is my answer. Hey guys, this video was helpful or useful in any way, please feel free to let the algorithm know about it. Like, share, comment, subscribe, even buy me a coffee if you're so inclined. Links for that down below as well. Thank you so much for stopping by. I hope you have a great day. See you later. Bye.